Welcome to qnawire.
Here we have an ideal reheat regenerative Rankine cycle with an open feed water heater. Boiler pressure is 10 megapascals. Let's see here. Condenser pressure is 15 kilopascals. The reheat pressure is the reheat pressure here is 1 megapascal. And here the feed water heater pressure is 600 kilopascals. We have steam entering the turbine at 5 and at 7 at let's see here, where is it? 500 degrees C. So that's what we know about this guy. So we want to find the fraction of the steam extracted for regeneration here, and the thermal efficiency of the cycle. So, all right, let's see here. We actually never wind up getting the fraction off here because basically that didn't wind up being part of anything we needed to find. So that's kind of an interesting observation. So we can start looking at coming out of the condenser. Let's see here. These we have everything is isentropic in this case. So coming out of the condenser, we know the specific volume, we know the pressure difference across the pump, so we can get the work that's being put into the pump, the specific work, and then we can get the enthalpy coming out of the pump. We know at 3, again, we have the pressure, we know it's a saturated liquid, so we can get the enthalpy at 3. We can get the specific volume at 3, and again, knowing the specific volume and the difference in pressure across the pump, we can get the specific work of the pump, and that allows us to get the specific enthalpy coming out of the pump. At 5, we have a pressure of 10 megapascals and a temperature of 500 degrees C, so we can get the enthalpy and the entropy. At 6, we know the entropy is the same as at 5, and we know the pressure. So that allows us to get the enthalpy at 6. At 7, we know the pressure and we know the temperature again, so we can get the enthalpy and the entropy at 7. At 8, we know the pressure, and now we know that the entropy is the same as that at 7, so we can get the enthalpy at 8. At 9, we have we know the pressure, and we know the enthalpy at 9. The entropy at 9 is the same as at 7, so that allows us to find the quality factor at 9 and the enthalpy at 9. So again, just kind of working our way around here, using the information that we have. Now again, we do an energy balance on the feed water heater, and that will give us this ratio Y of, I guess I missed a little dot in there, a m.8, which is what's coming, the fraction that's coming off of here, as opposed to what's going out here and then winds up back coming into the turbine. So that winds up being about 14.4%. So at this point, we're taking about 14.4% off. Here, we didn't ever need to calculate that. Now, we can look at the heat transfer in and the specific heat transfer in, the specific heat transfer out, and then the efficiency is just 1 minus Q out over Q in. So that winds up being simply 42.1% is the thermal efficiency.